we now define what we mean by simple systems and complex systems. The main issue here is the modes of work for a system. We know that a given system can have any number of modes of work. Thermodynamics does not put any restriction on this. We also know that some of these modes of work are two-way, for example, expansion of a gas. Some others could be one-way, for example, stirring a liquid. An important number for us is the number of two-way work modes. Let's call this N2W, represents the number of two-way work modes possible for a system. As an example, let's consider system as a simple gas, say air. In this particular case, the number of two-way work modes is 1, that is the expansion work mode. We consider another example in which we take the system at, say, a dielectric fluid, in which case the number of two-way work modes could be 2. One of them would be expansion compression, the second one would be charging discharging. It is also possible for a system to have 0 number of two-way work modes. For example, if you take an incompressible liquid, in this case we can say that the number of two-way work modes is 0. Why? No expansion compression possible. It is not a dielectric, so charging discharging is out of question. Can be stirred, but that is a one-way mode of work. So here we have seen illustrations of systems where you can have a single two-way work mode, or a system with 2 two-way work modes, and even a system with 0 two-way work modes. Using this number, we are now going to classify the systems, and this classification will be useful later. For example, if the number of two-way work modes is 1, we will call that system a simple system. If the number of two-way work modes is greater than 1, 2, 3, 4, we call that system a complex system. And if it turns out that the number of two-way work modes is 0, or the system is constrained such that it cannot execute any two-way work mode, we will call such a system a rudimentary system. Rudimentary systems, we will see, will be useful when we consider thermometry and the measurement of temperature. Most of our illustrations and many of our engineering systems will be simple systems. And because we come across a large number of different simple systems, it is often possible to classify the simple systems into some subclasses. For example, a single work mode, we mean a simple system. But in that work mode, if this single work mode is that of expansion compression as that of a gas, we will call it a simple compressible system like that of a gas. If that single work mode is that of electrical charging or discharging, as in a rechargeable battery, we may call it a simple electrical system. Okay. Take for example a spring, a rubber band. You can extend it or you can compress it, as in case of a spring. This will be a simple elastic system. We should notice that only simple systems can be described thus, using a single adjective, like a simple compressible system, or a simple electrical system, or a simple elastic system. Complex systems will need more than two or more adjectives. Thank you.